Today our objective is again to solve quadratic equations using the zero product property. We're going to use the same process that we used yesterday. We're just going to try some harder examples. So the first step to solving using the zero product property is to rearrange your equation so that it is in the form something x squared plus something x plus something equals 0. This is called standard form. And remember, in order to use the zero product property, you have to have your equation equal to 0. Our next step will be to factor the equation so that we end up with something times something equals 0. And then finally, we will solve by setting each factor equal to 0 and taking advantage of that zero product property. Let's try a few examples. So for each problem, we're going to go through the 3 steps of setting the equation equal to 0, factoring one side, and then setting each factor equal to 0 and solving. So in our first problem, the first thing we need to do is set our equation equal to 0, meaning this 12 needs to be moved onto the other side. So I am going to subtract 12 from both sides of this equation, and I will get x squared minus 4x minus 12 equals 0. Next, I will need to factor the equation. I'm going to first look to see if there's a GCF, but there is not a GCF, but an x squared and negative 12. So my next step is to try to do the reverse box method. So we'll set that up by finding our magic numbers that need to multiply to negative 12 and add to negative 4x. And those numbers are negative 6 and 2. Negative 6 and 2 multiply to negative 12. Negative 6x and 2x add to negative 4x. So I'll set up my box. My x squared goes first. My negative 12 goes last. And my magic numbers, negative 6x and 2x, go in those top right and bottom left boxes. So my factors, when I GCF factor up, I'll get an x and a negative 6. X times x is x squared. X times 2 is 2x. And I check negative 6 times 2 is negative 12. So now my factors are x minus 6 and x plus 2 equals 0. So my factoring step is done, and I'm ready to set each factor equal to 0 and solve. So if x minus 6 equals 0, then x must equal 6. And if x plus 2 equals 0, subtracting 2 from both sides gives me x equals negative 2. And then if I want, I can go back and plug those in and solve and make sure that they make my equation true. Okay, so if we check in on the 6, we can see that 6 squared minus 4 times 6 is 12. And if I check in on the negative 2, I see that negative 2 squared is 4. Minus 4 times negative 2 is 8, and 4 plus 8 is 12. So both of my solutions make the equation true. In this example, we will again need to set our equation equal to 0. So step 1, to set my equation equal to 0, I'm going to need to subtract 9 and add 3x to both sides of my equation. 3x and minus 9. I want to make sure that on the left I keep this in standard form. So 2x squared plus 3x minus 9 equals 0. Now I'm going to look for a GCF to see if I can do GCF factoring, but 2x squared and negative 9 do not have a common factor, so now I'm going to look for a reverse box method factoring. My magic numbers are going to have to multiply to negative 18, and they are going to have to add to 3x. The numbers I can think of that do that are negative 3 and positive 6. So negative 3x and positive 6x will be the numbers that go in the box. So 2x squared top left, negative 9 bottom right, and then my negative 3x and my 6x go in these extra boxes. GCF on the top row will give me a 2x. GCF on the bottom row gives me a minus 3. 2x times x is 2x squared. 2x times 3 is 6x. And I'm going to check with my 3 times negative 3 is negative 9. So my factors are 2x minus 3 and x plus 3 equals 0. Finally, step 3 is that I am going to set each of my factors equal to 0. So either 2x minus 3 equals 0, adding 3 to both sides, I get 2x equals 3, and x is 3 halves. And setting x plus 3 equal to 0, I subtract 3 from both sides, and I get x equals negative 3. So my solutions are x equals 3 halves and x equals negative 3. And if I want, I can plug them back in and check to make sure that they make my equation true. And when I plug back in, if I plug in the negative 3, I get that 2 times 9 is 18, and 9 minus 3 times 3 is 9 plus 9 is also 18. If I check the 3 halves, I get 2 times 9 fourths. That's 18 fourths is 4.5, and 9 minus 4.5 is also 4.5. So both of these x values are solutions. Our last example is a preview of a special case, but I want to show you that there's actually 2 ways to do this problem. So you might look at this problem and say, I can already do that in my head. I know that 3 squared equals 9, and I know that negative 3 squared equals 9. So you can kind of think to yourself that you know these solutions are x equals 3 and x equals negative 3. But let's just make sure that we can also do this by factoring. So if I subtract 9 from both sides here to set this equal to 0, I get x squared minus 9 equals 0. I'm then ready to factor. In my factoring step, I don't have a GCF, so I'm going to have to do the box method. I'm going to multiply 1 times negative 9 to get negative 9, and then I need 2 numbers that add to my x term, and I don't have an x term here, so that's 0x. So I'm looking for 2 numbers that multiply to negative 9 and add to 0 or 0x. And those numbers are 3 and negative 3. 3x and negative 3x. So if I use this reverse box factoring method, I get x squared in the top left, negative 9 in the bottom right, and then 3x and negative 3x to add to 0. My GCF on the top row is x. X times x is x squared. X times 3 is 3x. X times x is x squared, and x times negative 3 is negative 3x. So my factors are x plus 3 times x minus 3 equals 0, and I can then set each factor equal to 0. If x plus 3 equals 0, subtracting 3 from both sides, I get x is negative 3, and if x minus 3 equals 0, then adding 3 to each side, I get x equals positive 3, which is exactly what we got when we took the square root of both sides. So the other way you could do this problem is by using this method of taking the square root of both sides, and this is a special case. So a special case is if I have a 0x term, then I can get the x squared terms on one side, and I can get the number terms on the other side, and then I can take the square root of both sides. So in this case, if I have x squared and 9, I can say that x equals the positive or negative square root of 9, which is positive or negative 3, which is the solutions that I got before. We will talk about this special case again if you do lesson 13 on Thursday, which is a lesson on completing the square and then making use of this method of taking the special case method of taking the square root of both sides. And we'll use a generalized form of this method called completing the square. So our objective today was to review solving using the ZPP, the zero product property that we learned yesterday, and also to focus more on factoring And our big skill that we practiced today was setting an equation equal to 0. So remember, we can only use this zero product property solving method if we have already set our equation to 0.